Hey guys, have you heard about Internet of Vehicle? And today I would like to share with you guys about Internet of Vehicle. Hello, my name is Hazrol. I'm from CS708. IoV. It is the new era of the Internet of Things, is driving the evolution of conventional vehicle ad hoc networks into the Internet of Vehicle. With the rapid development of computation and communication technologies, IoV promise huge commercial interest and research value, thereby attracting a large number of companies and researchers. So in this video, I would like to tell you guys about network model of IoV, discusses the technology required to create the IoV, presents different applications based on certain currently existing technologies, provide several open research challenge, and last but not least, describe essential future in the area of IoV. According to the recent prediction, there are 25 billion things will be connected to the internet by 2020, of which vehicle will constitute a huge significant portion. With increasing number of vehicles being connected to the internet, the conventional vehicle ad hoc networks, which is VANET, are changing into the Internet of Vehicle. Vehicle ad hoc network transform any participating vehicle into a wireless router or mobile nodes, as it is well known for allowing vehicle to communicate with each other, and in turns it will establish a wide range network. Next, VANET also only covers a very small mobile network. Other cars may join in when vehicles fall out of the signal range and drop out of the network. Other vehicles can join in for linking vehicles to each other to create a mobile network. But bear in mind, it is just for a temporary, because it is also random and unstable network connection, and the range of usage is local and discrete, and it is also cannot provide for a whole global and sustainable services application for customer. Next is network model of IoV, network model of Internet of Vehicles, in which the model is composed of a swarm model and individual model. Integration of people, vehicles, item, and the environment is the main features of the network model. Human terminology in IoV applies to all persons who use or offer IoV services and application. Human being not only includes individuals in cars such as drivers and riders, but also individuals in IoV settings such as pedestrian, cycle, and family members of drivers. Vehicle applies to all vehicles that consume or offer IoV services and application in IoV terms. Staff apply to any aspect other than human and vehicles in IoV terminology. Staff may be inside or outside cars such as AP or highways. The words applies to the mixture of people, cars, and objects. On one car, the individual model focuses. IoV can provide resources for the cars, people, and the object in the vehicle by relation between human and the world, vehicle and environment, and things and environment. Technology and application. The first one is activation of IoV. It is used wireless connectivity technology to carry the vehicle into the advanced IoV network. It is also existing wireless connectivity system, which is WLAN, WiMAX, cellular wireless, and also a satellite communication. It is also a standard-based WiMAX IEEE 802.16 that capable of covering a wide geographical area up to 50 km. It is also provides substantial end-user bandwidth potential up to 72 megabits per second, while IEEE 802.16 standard only allow to fixed wireless internet communication. 3G, 4G and LTE are used with cellular wireless. Present 3G network transmit data to moving cars at a maximum of 384 kilobits per second and a maximum of 2 megabits per second for fixed node. Compared to WLAN and WiMAX network, 3G system have better hands-off, and several noteworthy works have been proposed. Last but not least, the most effective technology for launching in the inter-vehicle network and enable the IoV should be 4G or LTE. The next one is IoV application. There are two main groups of IoV application. There are security and also consumer application. The collision avoidance solution broadly perform two roles, which is collision detection and also driver assistance. There are methods recommended for crash avoidance of multiple vehicle and intersection, which is computer efficient control law, hybrid algorithm, which is crash avoidance supervisor, the smart intersection, which is convenience, protection, and efficient, and last but not least, it is smooth vehicle coordination. Two simple user-related resources by user application, which are cooperative local services and also global internet services. Next, it is cooperative local network, infotainment focuses, software that can be accessed from community-based services. Last but not least, global web services is on data that can be accessed from global web services. There are three types of user case used in user application. Number one is allow cars driver view any information available on internet. The second one is enable small companies promote their access to nearby automobiles. And number three is allow service station without having direct connection to the cars to determine the condition of a vehicle. Number 4. Challenges and future works. Number 1 is network model and human vehicle infra model. The use of deep learning and cognitive computer along with the sharing of network link data through big data technology may be used. Next, creating a quantitative assessment framework of a typical criteria for network service. Number 3 is all the fundamental research problem through the service user engagement mode, evolution structure and pattern, and cognitive learning model development result in that will help evaluation of customer service behavior. Next is enhancing the potential for collaboration. There is still a network bottleneck associated with wireless connectivity components. The difficulties due to drastic shifts, inconsistent customer operation and network optimization priorities. And then the challenge is to achieve a constant supply of bandwidth for IoV traffic in the event of congestion. Next, the use of certain smart technology can increase the ability to connect and subsequently to decrease redundant network traffic. Number 3 is digital car cooperation technologies for driver. There are more and more vehicles will be linked to IoV with common in-car operating system. Large virtual vehicle with drivers can communicate with each other on IoV platform and offer a stronger network experience for vehicle and driver through the use of interactive technology. There are two levels of cooperation between simulate vehicle and driver. First, it is the sensing of data and selection of physical vehicle with drivers. Number 2 is interaction and assessment of virtual vehicle with driver. Number 4 is the sustainability of the offering of services. First one is the challenge is to ensure the viability of IoV service provision, calling for high intelligence strategies and friendly network process architecture. Next, the difficulties are to provide real-time sustainability connectivity over heterogeneous network. And then, in order to ensure the longevity of the IoV infrastructure, need to consider its operation that offer limitation in real time under extreme network, extreme bandwidth demands, network capacity, and also restricted wireless network bandwidth. And finally, we are here for the conclusion. IoV is emerging as an important part of the worldwide propositioning and growth of smart or intelligent cities, as well as a dynamic interconnected network infrastructure that interconnects people in and around cars, onboard automobile, intelligent system, and in urban areas, separate cyber physical system. So that is all for me. I am Ahmad Hazrol, presenting for high speed network for Internet of Vehicle in Internet of Things. Thank you.